Hello everyone. Here the question says a series resonant LCR circuit. So this is a LCR circuit. This is a resonant LCR circuit. This is very important. As a quality factor, that is Q factor 0.4. Okay, and if resistance is equal to 2 kilo ohm and the capacitor which is present in there is 0.1 microfarad, and find the value of inductance. Okay, we have to find the value of the inductance. Okay, so according to the Q factor, what is meant by Q factor? Q factor is equal to the resistance acquired by the inductor divided by the resistance acquired by the resistor, or the Q factor can be explained as is equal to the resistance acquired by the capacitance when it is in the alternating source divided by the resistance present in the series. Okay, so this is the Q factor. Both are correct. Any value you can able to use, any value, any one of the value in this equation. I'm going to show you the both the values. Okay, so Q factor, here the Q factor is equal to, so we know that XL, okay, XL is equal to omega L, right? And XC, the resistance acquired by the capacitance, is equal to 1 by omega C. Okay, here at resonance, resonant means, it means the resistance acquired by the capacitance is equal to the resistance acquired by the inductor. This is known as resonant. Okay, so if this both are equal, then the value, yes, now I am going to show you the value, how the value has been came here right now here. So XL, if XL is equal to XC, okay, XL is omega L, which is equal to XC, right? XC value is 1 by omega C. So omega, from this, omega square is equal to 1 by LC. Okay, when taking square root on both sides, we will get omega is equal to root of 1 is going to be 1, remains 1 by root of LC. Okay, here I am going to write the value of XL is omega L, right? Omega L by R, and as well as XC, we have to write the value of XC is equal to 1 by R. So XC value is omega C, 1 by omega C, right? When you substitute here and when you substitute here. So I'm going to continue the equation with, okay, yes, now Q is equal to, what is the value of omega at resonant? So here the word resonant means omega is equal to 1 by root of LC. Okay, 1 by root of L into root of C. So I am going to split both the values, and L can be written as L, normally L can be written as root L into root L, root L into root L. Okay, so this is L. Okay, root L into root L. I am going to write as L as root L into root L, root L into root L by R. We left R, right? So the value of omega is written right here. So here I am going to show you the value of omega is written like this. So this is the value of omega, and the value of L is going to be written as like this. So root L into root L, and R written as R, right? Okay, so this is the thing you have to understand here. So I am going to continue the equation. So here root LC, so this root L get cancelled, the remaining thing is equal to Q is equal to root of L by root of C is into 1 by R. This is the remaining value here. So this value can be written as, this value can be written as So this is the Q factor value right here. Q factor is equal to 1 by R into root of L by C. So what is written here, I am just rewritten the same equation, and I am going to show you in the right hand side also, right? So yes, now here as this is the resonant, so omega value will be substituted here, right here. Okay, now Q is equal to 1 by R into omega, right? Omega value is 1 by LC. Then 1 by omega can be written as, okay, root of L into root of C. Root LC can be written as root of L into root of C divided by C. Now as it is, C can be written as root C into root C. Root C into root C. So root C into root C. Okay, now I am going to cancel this root C and this root C. Now remaining value here is Q factor is equal to 1 by R into root of L by C, whole root of L by C. So this is the value of the Q factor. So we know the value of Q factor right now, and now we are going to substitute the values here. So we have to find the inductance. So I am going to rewrite the value of, okay, now we found that Q factor is equal to 1 by R into whole root of L by C. So now this to find the value of L, Q into R is equal to root of L by C, whole root of L by C. So now I'm going to take squaring on both sides. We can get Q square R square is equal to L by C. Now the inductance value can be written as, so the inductance is going to be equal to capacitance and square of Q factor value and square of resistance value. So this is going to be the formula right here, and we can able to substitute the values right here. Okay, I'm going to use blue color. Yes. Now the capacitance is 0.1 microfarad. The capacitance is 0. L is equal to, the capacitance is 0.1 micro. It means 10 power minus 6. Micro means 10 power minus 6. Farad is the SI unit of capacitance. And into the Q factor, what is the Q factor is given, square of Q factor is 0.4. Q factor is 0.4, 0.4 square. Okay, Q factor into the resistance. What is the resistance given right here is 2 kilo ohm. Resistance is given here is 2 kilo ohm. 2 into 10 power 3 is kilo ohm. We have to write square as per the formula. Okay, I'm just continuing the equation. So inductance is going to be equal to 0.4. It can be 0.4 of 0.4 into 0.4, so the 16, right? So 0.16 will be written there. So 1 into 10 power minus 7 into 0.16 can be written as 16 into 10 power minus 2, 16 into 10 power minus 2 into, so 2 2s are 4 and into 2 3s are 6, 10 power 6. So now here 4 16s are 64, 64 into, okay, 4 16s are 64, 10 power minus 7 minus 2 is 9, 10 power minus 3, the remaining is 10 power minus 3. So, okay, the inductance value is 64 into 10 power minus 3. 64 into 10 power minus 3. The value is 64 into 10 power minus 3 is the value of the inductance. Henry is the SI unit of inductance. Here the option B is the correct answer for this question. Thank you.